The content point I've chosen to focus on is observe behavioural and structural adaptations of plants and animals and suggest how these might help them survive in their environments. For this task, I started by creating a diagram of koala adaptations and spinifex grass adaptations. This is my diagram of the features and adaptations of a koala. During my research, I found that koalas have adapted to have strong limbs and sharp claws. Their powerful arms and leg muscles give them the strength to climb, while their sharp claws help them cling tightly to tall eucalyptus trees. This is an important adaptation because koalas spend most of their time in trees. There, they have their primary food source, eucalyptus leaves, and they stay protected from ground-dwelling predators. As for spinifex grass, which is commonly found in coastal dunes and dry inlands of Australia, this plant has several structural adaptations that helps it survive heat, strong winds, and low rainfall. One feature is its silvery outer leaf surface, which reflects sunlight and prevents moisture loss. Another important feature is its deep root system, which allows it to access water deep underground. It also stabilizes sand dunes, protecting both the plant and the surrounding environment. Koalas have strong muscles in their arms and legs. These muscles give them strength to climb tall trees where they can find food and protection. Here I've sculpted some clay muscles to represent the koala's real muscle structure. Notice how it can cling firmly to the tree trunk? Without these strong muscles, a koala would not be able to hold itself securely onto the tree and might fall. Therefore, their strong muscles are essential for climbing efficiently and safely. Also helping them cling onto trees, koalas have sharp claws that grip bark tightly, preventing them from slipping and allowing them to climb with ease. These claws demonstrate how easily a koala can cling onto trees. Without these claws, it would be much harder for koalas to hold on to trees. Spinifex grass has silvery shiny leaves. This shiny surface reflects sunlight and prevents moisture loss. To show this, I've set up this model. This container of water represents the plants. The velvet-covered lid represents the shiny reflective surface of the leaves, and our ball here represents the heat and sunlight. Here, the sunlight bounces off the reflective surface and the water stays cool. This is what happens in real spinifex leaves and helps to prevent excessive evaporation and water loss. Now, if we remove the reflective surface, the sunlight directly hits the water. Without the reflective surface, heat is able to enter the plant's water supply. This represents how a non-reflective surface would lose moisture more quickly. Spinifex grass also has a very deep root system. These roots anchor the plant in loose sand and reach underground water, allowing it to survive long dry periods. Here on the left, we have short strings representing shallow roots. On the right, we have long strings representing the deep root system of spinifex grass. The cotton balls here represent sand. At the bottom is the underground water supply. This demonstration shows the impact of harsh winds on the different root structures. While the short root structure blew away with the wind, the deep root system is anchored firmly, reaching down into the wet cotton ball sand below. This shows how spinifex grass survives harsh desert conditions and also stabilizes sand dunes, helping the ecosystem. During the preparation and construction of the model, students engaged in learning experiences that addressed these following science outcomes. In relation to ST7090, students observed and applied their understanding of behavioural and structural adaptations of koalas and spinifex grass. By designing their models, they considered how these adaptations support survival in Australian environments. Through ST3DDT01, students developed their own design ideas, building prototypes using trial and error to test and modify their design to create a model that accurately represents animal and plant adaptation. Finally, for ST3CWT01, students used multimodal elements to plan and document their scientific understanding of their chosen plant and animal, demonstrated through labeled diagrams, annotations, and notes explaining the concepts and processes behind their model. Before beginning the model task, these are the skills students need to develop. Students should be able to make meaningful observations and describe features of plants and animals. Students should also have experience with planning and designing models using labeled diagrams to communicate and visualize their ideas. Additionally, students should also know how to select appropriate materials for the model and feel confident to experiment and problem solve during construction to improve their model. These skills ensure students have the foundational knowledge required to engage in designing and producing a model that demonstrates their scientific understanding. To ensure students have this necessary prior knowledge, preparation for this task will begin 6 weeks prior. In Lesson 1, students will explore the basic needs of living things, differentiating between the needs of plants and animals, and what helps them survive in their environment. In this lesson, students will learn the features of plants and animals. Lesson 2 will cover Australian habitats and environmental conditions. This content will help students build understanding of Australia's different landscapes, prefacing to students that plants and animals require different adaptations to survive in different terrains. Lesson 3 shifts its focus to koalas and their adaptations. This could involve an excursion to the zoo or koala park, where students are able to make observations on structural and behavioural features of these creatures that support their survival in their environment. Lesson 4 puts a focus onto spinifex grass adaptations. Referring back to the learning about Australian terrains, this lesson explores how this plant's adaptations help it to survive in its harsh environments. In Lesson 5, students will plan and design their model, testing materials that could be used towards their construction. Supported by a yarning circle to share and refine ideas collaboratively, this lesson will explicitly teach how to create labeled diagrams showing key adaptations and explore selecting appropriate materials. By Lesson 6, students will have the skill set and prior knowledge for this task, being well prepared for when they need to apply their learning to construct and present their adaptation model. In Lesson 5, we incorporate a yarning circle as a respectful and collaborative way for students to share their ideas and plan their model designs. Rooted in Aboriginal and Torres Strait Islander traditions, a yarning circle is typically used as a method of teaching, learning, and decision-making. For this instance, we will be using our yarning circle to discuss and communicate about the planning and design of our adaptation models. This discussion will enable students to start thinking and discussing collaboratively about the sourcing of recycled materials to promote sustainability, solidifying their designs, experimenting with different approaches, and learning from their mistakes. This discussion would ultimately help students to select the most effective method and design to proceed with for their model construction. To ensure students' learning is staying on track through these 6 lessons, their understanding will be assessed through both formative and summative assessments across these 6 weeks. During Lessons 1 to 4, we will be applying formative assessments, including class discussions, sorting and matching tasks, exit tickets, and teacher observations. These assessments will help the teacher monitor student progress and make any necessary adjustments to following lessons to correct misconceptions. Lessons 5 and 6 will utilize summative assessments where students will apply their learning. For Lessons 5, students will be assessed on their labeled diagram and plan for their model to show adaptations. In Lesson 6, students are building and presenting their model to demonstrate and assess their understanding through design and explanation. It is essential to ensure learning is tracked throughout these lessons, as this will ensure students have the required skill set to be well prepared for when they need to apply their learning to construct and present their adaptation model. This task also crosses over to other links connecting multiple curriculum areas, priorities, and capabilities. For KLA links, English is linked as students are building comprehension skills through reading informational text and expressing their understanding using scientific language in labeled diagrams and reflections. These skills help them clearly communicate the features and functions of adaptations in their models. Design and technology and visual arts is also a fundamental aspect of this task. Involving planning, designing, and building their models, this task uses creativity to explore textures, colors, and forms when creating their model in a realistic and meaningful manner. Additionally, Aboriginal and Torres Strait Islander histories and cultures is embedded in this task as we incorporate yarning circles to promote respectful sharing and reflection. Sustainability is another cross-curriculum link explored in this task, as students make considerations of recycled materials as well as discussions about protecting Australian habitats and how certain flora adaptations protect both the plant and the surrounding environment. Additionally, some general capabilities are also developed throughout this task, such as critical and creative thinking, personal and social capability through collaboration, and ICT through researching and designing diagrams using digital media. Altogether, these elements make the model task a rich and authentic learning experience that builds scientific understanding while developing essential skills students are able to use beyond the classroom.